All right, good morning, everyone. I'm trying to talk about Mocha and Chai today. Oh, I put an I in. Okay. Oops. Cool. Has anyone here used Mocha or Chai before? Nice. I'm happy to just kind of dive in and tell you what I think is important and what I think you should know, but if anyone has any specific questions that you have about Mocha and Chai now, maybe we'll go list those so I can try to work them in. Nope. Nobody's confused about Mocha and Chai? No questions at all?
Don't know enough to have questions.
Don't know enough to have questions. All right, cool. Oh, yeah, hi.
Hi. I'm really comfortable with using the expect library in Chai, but I'd like a little introduction to using assert instead.
Oh, okay. Yes.
Like, what is the difference between Mocha and Chai? Like, they're both for testing.
Sure, sure. Sure, Mocha is a testing framework, and Chai is an assertion library. Yeah.
So far, it seems like it can only test, I guess when you're doing unit testing, what is returned out of a function. Is there any way to test states of variables?
There's all kinds of way to test. There's no way to know. If I run a function and it uses a variable internally, that's not accessible by anyone outside of that function.
Okay.
The only thing you can test, and this is more of a philosophical thing, the only thing you can test is the side effects of a function. Right? So if I have a function that is called do, nothing, and it's a function that just does nothing, right? There's nothing for me to test, right? I can test that the return value is undefined.
So I used in the contacts command line, I created a function that did my reading and writing of files.
Yeah.
So is there a way to test that I passed this into it to write it, and then it actually wrote that? Because it doesn't actually return the file.
Sure. Right. So if we have so this is great. So if we have a function called read the file, and this function's job is to read the file and return its contents. Who cares how that works, right? So we want to test this. We want to make sure that this is reading the right file and returning the right thing, right? So we have to look at this like it's a black box, right? And we have to think about this function in terms of its inputs and its outputs. What is it? Where is it getting information from? And what is it going to change or affect? And you can think of returning as sort of another case, right? So like, what does it give back? Its return value. You could kind of think of that as a side effect or a change, but it's really just like it can give you information. So when we write a test like this, we're probably going to say something like, call read the file, and expect the return value of read the file to equal the contents we expect, right? And so how do we get the contents we expect? How do we know, right? So one way we could do this, if this thing really is just going and reading the file slash whatever.txt, right? Let's just say that's the file. This function knows that file. It's like built into this function. It's only ever going to go read that file. So you're asking like, how do you test that? Well, what you can do is before your test.
And that's more so for opposite situation when you're writing.
Sure, I'll show you. Yeah, it's going to be the exact same thing. So before the test, you write to the file, and we're going to write, I like cheese. And then we're going to expect that when we call read the file, we get back what we put in that file. And we might even come in here and throw like a math.random or something, like make sure that this is like unique to this test. And so we're going to store this in our expected contents. And then we're just going to write that to the file. And then we're going to call our function that is supposed to read from that file and make sure that it gave us the right thing, right? So we have no idea what's going on in the internals of this function. If we do, as we write this test, we should pretend we don't, and just think about the borders around that black box of that function. That function is reaching out to the file system and it's reading the contents of a file, so that's the border. And we want to go put stuff in that file, call the function, and make sure we got the same stuff. Then we don't have to know how the function works, but we know that if this file contains I like cheese, then that's what we're going to get back. And that's what we needed to do, so therefore it works. And it's the other way around is exactly the same thing. So we would just say, before our test, just call, let's say we'll call write to the file with some other random unique string that maybe has a math random in it or whatever, right? And then we're going to say expect, and then we're going to read that file manually, right? We'll do like an fs read file or whatever, right? And then we will assert that when I called this function, this unique content that I just generated is actually in that file. Right? So again, where you're like saying, hey function, here's some information, do whatever you want, but one of the things you better do is put that content in this file, and if you do that successfully, then this function does what it's supposed to do. And it works, right? Does that make sense?
So your expect would be reading a file and saying that the contents of that file is what you pass to your
Yeah.
Okay.
You know, this is pseudo code, but you know,
Right. Okay.
something like that. And we can write one of those tests. Cool. So that's like a good philosophical place to start, right? Is like, not this talk is mostly about understanding the tools of Mocha and Chai, but there's a lot to know about like this sort of philosophy around testing. Like, what should I be testing for? How do I know when my function is 100% tested and will always do what I want it to do, right? Testing is a very difficult part of writing good quality software. You'll often end up writing more test code than the actual code itself. Your test suite will often be bigger than your actual code base. So, right, because you write a function that just like reads a file, and now you've got to write 5 or 6 tests to make sure that that thing does what it's supposed to do. So you've got, you know, 100 lines of test code and 5 lines of code that you're testing, right? So it can get pretty cumbersome. And I've worked on applications where just to run the test suite for our application took 45 hours. So we had to take that test suite and break it up into parts of itself and run it across a distributed set of machines in the cloud so that we could run our tests in 1 hour. So like crazy large test suites to make sure that things are working correctly. There's lots and lots and lots of things that you can test. Cool. So let's get into the specifics of how to set up Mocha and Chai. And I'm going to say these as dev dependencies. Does anyone know why? These are dev dependencies.
You'll save them into the package file.
Well, what's up? Only need them in development, yeah. So save and save dev here are going to put them in the package JSON file and mark them as dependencies for this application. So when we do npm install on a fresh clone of this repository, we'll get those dependencies, but there are 2 kinds of dependencies, right? One's for development only, and one's for running in production. We're not going to run our tests in production. We run our tests way before we send our code to production, right? So these tests only run in the development environment, or sometimes the test environment if you want to get fancy. So, but we'll install them as only dev dependencies. So that's going to put them in our package JSON file under dev dependencies here.
What's the I have to do?
Oh, install, sorry. I try not to shorthand, but yeah, npm install is what that command was. Yes.
So when you, on a fresh, like clean, like let's say I have just cloned this repository and I did npm install to just install all the dependencies,
It will.
Would it still install the dev dependencies even if I'm only using this?
It does, it does. I believe Node will also look at the node env environment variable. I happen to have mine set to development. If it was empty, it would default to development. But if I put node env to production, my guess is npm install would not install the dev dependency. So there's this environment variable called nodem that kind of dictates the name of the environment that you're in, and there's meaningful differences between production and development, and I think NPM follows that pattern as well. Cool. Great. So now we have these dependencies installed. So let's make something worth testing. So I'm gonna make just gonna make, what should we make today? Anyone have a good idea? I'm making a thing. A silly idea.
Calculator.
I always do a calculator. All right.
Puppy rental store.
A what?
Puppy rental
A
store.
puppy rental store.
See, you complained about a calculator.
All right. All right. Let's do it.
Okay.
All right. So I am going to do module.exports. Huh?
No, fuck.
Oh, I don't even know how I'm going to test this. This is ridiculous. All right. I can't do this. God, Michael.
Can we just sort something?
Sort something. Sure. Great. So this is going to be a function that takes an array, and it is going to return a sorted version of the given array, sorted by case insensitive alphanumeric. Yeah. So we're going to return some version. So I'm not even going to write this thing first. I'm going to write the test first. So there's a couple of ways you can do this in terms of where you put your tests. You can put your tests wherever you want, but Mocha has a default where they want you to make like a test directory. I think it's singular. And then they, but this is just a suggested pattern. And I'm going to put .test.js. Okay, so I can't make this sidebar much bigger, but basically we've got our sort by case insensitive alpha function here, and then we've got the test for it up in this test directory. Make sense so far? Everybody follow that? Cool. All right, so Mocha is, so normally in Node we would start requiring things if we wanted to use things, right? Like if I wanted to write this describe function, which I want to do, describe sort by, so describe this function. Normally I would expect in Node that if I'm going to be using these new methods from a library, I need to go require them, right? You'd expect to do something like describe equals require from Mocha or something like that. But what happens, what's different about this, and I think it's actually a little bit weird about Mocha, is that Mocha provides global variables to you when you run the Mocha command. So we're not going to be able to run Node and just run this file. We actually have to run this with Mocha to run this file. And when you run it with the Mocha command, it's actually going to provide a global variable called describe and a global variable called it. And so it should take an array and return an array. What's up?
I just didn't hear the second variable.
Describe an it. It. So these two variables, describe and it, and there's another one called context too, but there might even be more, but these are the two main ones. And so these two methods are here to allow you to describe a sort of nested tree of tests. So it doesn't need to get that complicated, but basically you'll say, describe a thing, this should be a noun, and then this it block should be some aspect of how it works. So we could do a simpler case. It should be a function. So sort by case instead of alpha should be a function. So I need to actually get this. So I'm going to say const equals require .. that file. right? So if you remember, we have our source file here, and then in test we have our test file. So from within our test file, we have to go up one directory to go get the actual thing we're testing. I know I'm moving a little fast because I want to cover a bunch of stuff, so if you're lost, just let me know what you're confused about. So please interrupt me. Cool. Okay, so this thing that we got that was exported from this file should be a function. And it should be. So let's say expect this thing to be a function. And this syntax that I'm writing here, this expect syntax, this is this is where we jumping into chai land now. So I'm going to write this one test, I'm going to get it to work, and then I'm going to walk through it again, and I'm going to explain what's Mocha, what's chai. We'll come back to this test. Okay, cool. So we ran Mocha, which ran the test describing this object that should have this behavior. And if I actually had exported something else, like a number from that file, the test would have failed. And it's what it says, expected 5555 to be a function, and it's not. If I, gave this anything other than a function, it's just going to error and say that that is not what you said it should be. Right? This expectation failed. So what's going on here? So this is just your normal code file, nothing special in terms of testing going on here. In this file, we have describe and it because we're running this with the Mocha command. When we run Mocha, it's going to look in the test directory and it's going to run any tests that are in there. You could also run it like this, right? So when you run Mocha on one of these files, it sort of does this pre-initialization where it kind of loads itself and pulls in the describe and the it, makes some global variables, and then executes your test file. So that's what Mocha does, is it gives you this way of describing a certain test, right? So if I can illustrate this with another example, describe, if we were to describe an add function, we might say it, should take two numbers and return their sum, something like that, right? We might say something like this, context, when given 10 and 7, it should return 17, right? So we might write this in a bunch of different ways. It's kind of up to you. There's no perfect or proper way to describe something that you're building. You just want to use these tools where describe is for the thing that you're talking about. It is for a bunch of individual tests, right? So, and you can write this, you can write all the tests that you want, right? It should support negative numbers, right? If we needed to test that sort of thing, right? It should error, or it should throw an error when given strings. Whatever we need this function to do, we can break them up into individual well-worded behavior descriptions of the thing that we're trying to describe. So there's many ways to write tests for your code. This approach is using a sort of behavioral description to drive what code you're actually writing. But at the end of the day, this just all comes out. So if I put some, I think I need to have some expectations in here. I'm not sure. Let's run these tests. Yeah, so there's nothing in these tests, so they pass. But at the end of the day, you're just going to get this output saying like add should take two numbers, should support negative numbers, should throw, et cetera, right? So the describe and it serve two purposes. They serve a sort of like framing for naming these behaviors that you're testing, but they also sort of dictate this nice nested output that you have here, that we can get here. But really all Mocha's doing at this point is it's taking all of these it blocks and it's remembering them as tests that need to get run, and then it does this sort of first pass where it sort of collects the whole framework collects all your describes and context and its and sort of stores that in some structure, and then it starts going through tests one by one, and it runs each it block one by one. So you're going to see if I log these, they'll come back in some, oh God. All of these will get run in some order. Cool. So this structure of it's nested inside of describes and contexts, and this nesting structure. Is there any questions about this? Anyone need to get more clear on how this works?
Can you show real quick on the output where the context came in? Okay, so it just adds another little.
Yeah. So, yeah.
Can you do one for like handling error? Or expect, like,
Yeah, I'm going to get into actual testing and writing some expectations here in just a minute, but I just want to make sure that this part of Mocha where we haven't written any tests. We've just written the sort of the structure of what our tests are going to be, like the description of how our object should work. We actually have to write the test that says if I give it negative numbers, it works, and that if I give it 10 and 7, that it works, right? We still haven't done the work here, but we've started to describe to a human what this thing should do. So if that's clear, we can move into some actual tests. One more thing I'll say about this is that describe is, again, for an object. Context is for a state of the world sometimes. So we might be testing something that it works differently depending on the way the world is. So, for example, if I call a method asking me how many users I have in my database, depending on how many users I have in my database, that result is going to be different, right? So we might write something that says like describe, get user count as one of our functions, right? And we could just say, it should return 10, but that's not always true, right? So sometimes we need to like test something that's dependent on the way the world is at the time. So we might have a context that says when there are 10 users in the database, then this thing should return 10, as opposed to when there's 100 users in the database, etc. So we'll probably end up writing our code where we have like a before block here that actually does the work to make the world. Empty users table and insert 10 users. And then down here, we'll expect users count to equal 10, right? So, and then we might have another one where we say, okay, well, what does this function do in a different context? What if there are 0 users in the database? We just empty them out, right? It should give us 0. So that's what Mocha is for, is helping you structure what you're testing, what the world looks like in different states for which you need to simulate to test your function, and then it's sort of agnostic of how you actually test it. Mocha doesn't give you any tools to make any assertions at all. It just gives you this boilerplate kind of outer structure to define a series of tests that will execute in a specific way. So it provides like a before each and an after each and a number of different ways to, again, structure what you're testing. Yeah.
So you said because Mocha is running in Node, you can use anything that would work in Node to set up the before and afters?
Absolutely, yeah.
Okay.
Yeah. This is running in Node. Mocha is just running it in a special way for us.
Okay.
I think it's really annoying that we have to run it with the Mocha command and we can't just do what we normally do and like require Mocha and have it do its thing, but there's probably some good reasons for that.
Jared,
Yeah.
Whenever I do this, I run the command npm run test.
Right, and that's just an alias for running Mocha.
Okay.
Because that in those moments, your package JSON probably just says scripts test is Mocha something.
Yeah.
So it's the same as if you had just run that yourself,
Okay.
right? If I go into my package JSON here, and I change this test command to just be echo no way, dude. and then I run npm run or just npm test, it's like, no, right? It'll do whatever you tell it to do. So if you just run Mocha, npm test now runs Mocha, and then my tests run. Cool. Great. So now let's kill this example, and we're back to testing something that we can actually test. So when I ran these tests, this test failed. Oh, no, it didn't fail. It's good. Well, sorry. I meant failed in a, so, yeah, failed in I saw a different failure. I should have been more articulate, sorry. It did fail. So if we make this a function again, then our first test is passing, right? So I'm going to try to TDD this, right? So the very first thing is I know sort by case insensitive alpha, that should be a function. So I wrote a test, it should be a function. I expect that this object to be a function. This is where chai comes in. Chai is a library that you can use where that all it does is allow you to express statements, and if those statements are not true, it will raise an error. It will throw an error. Throw is the right word. It will throw an error. So if I just go into Node and I get chai, it knows nothing about Mocha as far as I understand. I'm actually just going to get the expect object from chai. Okay, and expect, yeah, expect is a function. It logged really weird. Type of expect is a function. Yeah, okay. So expect 1 to equal 1. And it has a return value, but we can ignore that. So I'm just going to do this. We don't care about the return value. So it just does nothing, right? It doesn't raise an error. But if I say expect 1 to equal 2, it throws an assertion error that says a nice error message saying, you expected this thing to be true, and it is not true, right? So that's how Mocha and chai work together. If I wanted to write this, well, let me say it this way. Mocha just runs this function to run this test, and if this function runs without raising any errors, without throwing any errors, then the test is considered a pass. So if we just have an empty test and we run Mocha, it's going to say it passed. But if I come in here and I throw a new error saying this test now fails with the error, this test sucks. So that's all expect is doing. If I say expect 1 to equal 2, this test will fail because Mocha's because chai, the expect method from chai, is throwing an error telling us that this expectation you made isn't true, and it reports that by throwing an error. But if I don't throw that error, the test is considered to be a pass. So these are two completely different libraries that they do not talk directly to each other. They're just in concert. One runs a function looking for errors, and if there are errors, the test fails. The other one checks assertions that you made, and if they're wrong, it throws an error. But they know nothing about each other, but they work together by communicating by one throws an error and the other looks for those errors being thrown. So we don't need a testing library. If we wanted to write something like this, we could say if type of sort by does not equal function, then throw a new error, expected this to be a function. So now this test passes because it's a function, but if I go make this a string, then we get the error, expected this to be a function. So does that relationship make sense? How we don't even need an assertion library, right? We can throw errors ourselves if we want to, and our tests will fail if there's ever an error.
Does Mocha itself have any assertion functionality?
Nope. Mocha ships with no assertion support. Yes.
In chai, I saw one of the tests you did. It said expected 2 to deeply equal 3, and I saw that somewhere else in the documentation where something was like
Sure.
expect 2 deep. So what is
Sure. As soon as we get into some more expectation stuff, we'll get into what deep means.
Okay.
But I just want to make sure that this idea of the difference between the testing framework and an assertion library is clear. Cool. Okay. So let's keep writing some tests for this. This is a pretty good test. It should take an array and return an array. So I'm going to say expect sort to take an array, and the return value should be an array. Oh yeah, this needs to be a function again. Okay, so our first test passed, but our second one should take an array and a return array didn't pass because it expected undefined to be an array. And that's because down here, the return value of this was undefined. Does anyone know why that was undefined, the return value?
We didn't return it. Is that the function?
This function here that we're calling in this statement here is this function up here.
Yes. Function's not returning.
The function doesn't return anything, and so if a function doesn't return, the return value is undefined. So we can come in here and just say return an empty array. And this is cheating, right? Because it's not actually doing the job that it's supposed to do, but this assertion just says it should take an array and return an array, and it took this array and it returned an array. So this is not exactly how our function should work, but it's a step toward the way that it should work, right? Okay, so now I'm going to do a context when given, and I'll just give it, this is an example. It should return, and I think it's like gonna be A, B, C, Z, like that. It's case insensitive alpha sort. Yeah, I think that's right. Okay, and so then we will copy this. So we're gonna expect this to equal this. And it said expected empty array to deeply equal this, and it did not, right? So this empty array doesn't match this because this to do what it's supposed to. So let's make it do what it's supposed to. So this is going to be an array, and we're going to return the array.sort with a function A and B, where we return A.to lowercase minus B.to lowercase. I might have this backwards, but let's find out. Yeah, I think I have it backwards. Maybe not. What'd you say?
Look like it added actually.
Well, it's doing this thing. Let's talk about thank you. Let's talk about this output, right? So one of the nice things about using an assertion library like Chai's expect or just any of Chai's assertions is that we get this nice output where the error message is actually colored like this, and it's saying we looked at this array and we compared it to this array, and this is sort of a diff output. It's kind of like gets diff, right? Where it says like there should have been a z here, but it's not, and there shouldn't be a z here, but there is one, right? So it's sort of showing you like the diff between this array and this array. Why are you not?
Kind of reminds me of like GitHub's like showing you
Yeah,
the changes.
exactly. I'm not sure why this doesn't work, so I'm gonna try a different approach here. All right, can everybody read this?
Did you chain to ternary
I did. Good observation. Yeah, this is the same as saying if A is greater than B, return 1. Else if B is greater than A, return -1, else return 0. So this is saying, so a ternary is a thing. If this is true, you get A, otherwise you get B, right? So it's this question mark and this colon. So if you say, if this is true, return 1, else, if this is true, return -1, else 0. Is kind of is what that's saying. It's a shorthand way of saying that. So if we need to play with this some more, maybe we'll switch to if statements, but I'm hoping this will work. There we go. Okay. So without getting too much into sorting, what this is saying if the lowercase version of A has a greater alphanumeric value than B, we're going to return 1. Otherwise, if it's the other way around, we're going to return -1. Otherwise, they're equal because neither is greater than the other, and so we return 0. And sort takes 1, 0, or -1. 1 being A goes before B, -1 being B goes before A, and 0 being they're effectively equal. Sort them however you want. Right? Make sense?
I was gonna do you really need to pass in 0 because you're not really doing anything? Zero, right?
Well, sort, if I had two strings that were identical, if I had two strings that were both frog, we wouldn't want to tell the sorting algorithm one goes before the other. We want it to decide what to do with identical sort valued items, right?
Does it only accept -1, 1, and 0, or just like negatives?
I believe it will. It's flexible enough to take greater than 0, less than 0, or 0.
I was gonna say that not divided.
Right? Because you can do numeric search just using subtraction.
Okay.
Right? Okay. Not search, numeric sorting using subtraction. Okay, cool. So now we have a function that works. So let's kill this thing. And we have a function that when you give it this array, it returns this array. So this is, pretty good for sorting. There's probably some other cases in here that we'd want to play around with to define to make sure that it worked in all the cases that we cared about. But you can see how I've sort of slowly, step by step, chosen individual behaviors and asserted that each one works the way that it should. One thing that I highly recommend when you're writing tests, however you're writing them, as soon as you get stuff to pass, commit that to a temporary commit or a real commit, however you want, but get it to a point where you've saved your code, and then make sure things break the way that they're expected to break, right? So if I come up here and I return a number, I expect these tests to break. If I actually don't do any sorting at all, I expect these tests to break, right? So what I want from my test suite is confidence. That's the whole reason we're doing this. So, well, some would say that test-driven development actually makes your code better, and I would agree in some cases. So writing tests can make the quality of your code better, but in my mind, the vast majority of the value that you're going to get from a test suite is ongoing confidence that things that you've written continue to work the way that they're supposed to as your code evolves. Most applications are too big for any one person to really fully understand, certainly not at any one moment, right? So what we need is, in order to go into an application like Facebook or Pinterest or whatever and go into these large applications and make aggressive changes, add a really big new feature, make a massive change to an existing feature. In order to go in and do that without risking breaking a ton of other stuff that may be related to what you've done in a way that you don't fully understand, we need to have tests that go through and make sure that the things that need to work continue to work. And when we have tests that cover our code base and their individual pieces with to a sufficient degree, we can confidently go into a code base and just like rip down walls and build new structures and just really make massive changes to a code base and then run our test suite, and it should tell us, if you have a good test suite, like what you broke, if you broke anything. And you will be surprised for years and years to come at all the different ways code can be dependent on each other that isn't obvious. So you'll go in and you'll make a change that you would swear is benign, but it has some side effect on some other part of the code because things were wired up in a way that you didn't understand, or there was one edge case that you didn't see of how you would get there, right? So the reason why I'm recommending that you go through once your tests pass and make sure they fail the way they're supposed to fail is because it's actually easier than you'd think to write a test that doesn't test anything. It doesn't test what you thought it was testing, so it passes, and now it's a false positive. So now you have false confidence that code is working. So really go in and make sure that, like, if somebody comes in and they're like, wait a minute, no, this should be the other way around, right? And they're wrong about that, I want to make sure that my tests will fail, right? So I want to go in and make some changes just to make sure that, like, this function does exactly what it's supposed to do, and the only way that it's going to not do that is if someone changes it and changes the test. And then presumably if another developer is coming in and they're changing the code and they're changing the test, that they better have some idea what the hell's going on, right? And other tests testing other parts of the application should catch any issues that maybe they rely on this function and now they're broken because you changed this function. But they should have their own tests, so that gives you greater confidence. So make sure your tests aren't bullshit, that they're actually doing what they're expected to do, right? Because if I accidentally, you know, I can't think of a great example, but if you for whatever reason, like let's say you write your code and this expect never fires, right? Your tests look like they pass, right? So then I come in here and I'm like, I didn't even, like, it looks like my test suite's good to go, and it's not. It's totally broken, right? So that's one step that I think is crucial, is that you go through and intentionally break your tests.
I wanted to ask you something. Well, I just forgot.
I'll come back to you. There's another question over here.
I saw in our modules we were saying that Mocha and Chai together can be used for both unit and integration testing.
Sure.
I see this seems to be mostly unit testing. You're testing one particular function or one module.
Sure.
When you're doing integration, do you set it up so that are you like receiving a result and passing it into another function, seeing how that trickles through, or are you just running your app? How does that normally work?
I mean, Mocha and Chai are two very generic tools. Okay. Mocha lets you define what a test is, what tests you have, and tells you which ones passed and which ones failed. Chai lets you make expectations. There's all kinds of other libraries that do things like spy on parts of your application to see what happened in the middle of something, right? So if we have an application that is a web server that takes a web request to create a book in our library API, and so we're going to do a post to some URL, and then that's going to go to a method that talks to the database, and maybe there's some validation in there. Maybe I'm going to write a test that does the post to that HTTP API, lets it fall all the way through into the database and come back and respond. So I'm testing both the fact that when I post, I get back a response, but then I'm also going to reach into the database and make sure that that change happened as well. So that's a way that you can do a more integrative test where you're like, all the pieces of my application are working in concert to do this job. If any one of them breaks, this test should catch it, hopefully. And you're asserting that not only did my web application receive a request and send me back an appropriate response, but it also had the side effects that I care about, which is that the data in my database now has this book in it. So really the difference between unit and integration is kind of just like how many things are at play here, right? Like, are we testing one thing in isolation? And if we are, we should be temporarily severing it from any other part of our application. We're going to be isolating it and testing it as a black box, right? If you have this giant media center at home, like, and you pop in that DVD player and into the DVD and into the DVD player and something doesn't work, you want to come in and you're like, okay, I don't hear the audio. Is it the receiver? Let's pull that out and test it independently. Let's pull the VCR out and test it independently, right? And make sure that when it's wired all together, we'll do an integration test and make sure that if I press pause on the VCR, what's coming on the TV no longer moves, right? I don't care what's going on or how it's wired together. That's kind of like an integration test. And you can do that with Mocha and Chai. You can do almost anything with Mocha and Chai because it's just saying, like, here's my 5 tests. Run those 5 and tell me whether they pass. And those tests could be like, could literally be going out. Like, we could use Mocha and Chai to test a website we don't even own, right? I could write a Mocha and Chai suite to go test, like, Facebook, that it goes and opens a browser and clicks on the login button and types my username and password. And then I go to my friends and it's got Will Wheaton. He's not my friend. You know what I mean, right? Cool.
Yeah, I wanted to ask, so if there's like 2 tests, and the first test is adding something to a data structure, how do we make it so that it resets when it reaches another?
Sure, that's a great question. That's a great question. Let's make another test case for that. Okay, so let's say we've got this little to-do list, and the way we want to use it is something like, oh my God, I can't type.
An extra space at the to-do list doesn't matter.
No. All right, so something like this, where we can call add, and it'll put that into this items array, and then we can look at what those things are, right? So let's see if this works. So I'll just go into Node, and I'll paste this in here. Oh, God. Oh, yeah, of course that's not going to work. I'm just going to test this really quick by hand. To-do lists. Cool. So it's just this really simple structure here, but your question was about, like, as I write tests for this thing, how do I reset what's going on? And the short answer is you just use like a before each block in your test. So let's make a test for to-do list. And so we're going to grab, and we're going to say describe the, oh my God, the to-do list. And we're going to say before, so let's say we're going to actually describe the add function. So you can nest describes. And we're going to say it should take a description and add it to the list. And so we'll say something like to-do lists dot add and then we'll say expect to-do list. God, I keep doing that. Dot items to include this string. Whoa. Oh yeah, this needs to go. Okay, so we're gonna run our tests. Oh, and I don't have expected, forgot. Thank you. All right, cool. So expected this array to include this. This is actually wrong. But let's see, to include description. Is that going to work?
Description has a capital L.
Thank you. To include is not going to work because these are not the same object. So let's just stay simple here. There we go. Okay, cool. So we're testing this little fake to-do list thing, right? And we also want to say something like expect the item's length, you know, to equal 0 when we start. And then afterward, we want it to equal 1, right? Because we just added our first thing, right? So this is going to work because we have one test. And every time I run this, it starts out empty. But if I had 2 tests, I'm just going to write 2 tests here that are exactly the same because I can't think of a second thing, but you'll start to get a problem here where the second test, the length is actually 1 instead of 0 because the previous test modified that object, right? So this is what's called like test bleedover, right? This is where the side effects of one test were not properly cleaned up so that they affect another test. This is a huge problem in testing because you can actually, the worst version of this is when your tests pass because of a side effect, and then when you like shuffle the order of your tests or you remove one of your tests, this other test fails, and now you've revealed this like inner dependency that was totally implicit and no one was aware of. So how do we clean up after each test? And this is an example of that. We're going to put a before each. So every time we run a test, anywhere inside this describe block, we're going to say before each of those tests, go into our to-do list and just reset items to be an empty array. That's an example of cleaning up, right? So now each test starts in the same state where we have their to-do list and the array is empty. So this is a manual, very simple example. A more complicated example of this would be like working with a database. If you were writing tests for commands that read and wrote data to your database, you would want a reset before each in your test suite that's going to like reset your database to some known same state. Usually that state is empty, right? So if we're testing some functions that are like add this user to the database, get this user from the database, and delete this user from the database, before we write tests, the 10 or 15 tests we'd write for all 3 of those methods, we'd want to say go empty out the users table. So I know where we're starting. Because if you don't know where you are, you don't know you can't measure the change, right? Is that clear?
Yeah, I also read somewhere that there's a way to generate fake data or something like that, like data that you can work with, but that does not really exist.
Sure. you probably don't need this very often, but I mean, let's say we were working on building a Medium, right? That blogging platform, right? So they have a big application, they have a big test suite, right? And at some point in their test suite, they're probably generating a bunch of fake blog posts, right? And so rather than the developer going into the test suite and say, okay, create 5 blog posts so that I can test the comments or something, right? Rather than having a test that's like, my first blog post, I like cheese, right? They'll probably have some library that's like a fake content generator library that's going to say, generate 5 blog posts with random titles and random 5 paragraphs of content. And that just comes from lorem ipsum, or it comes from some random generator, right? And there are a bunch of people have written some funny ones like hipster ipsum and stuff like that, right? And that's just there to make it easier for you to generate essentially meaningless content that you don't necessarily want to just smash the keyboard for.
Well, I think what I was asking was more of like if you had, say, 2 files, and one file, in order for you to test that one file, it depended on the other file. But you just wanted to assume that the other file did what it did and only test that file. I don't know if I'm clear.
Yeah,
it's
say
like,
it to me again.
Let's say I'm building like a card game.
Okay.
And if I have like classes and stuff, there's like there's like a deck class, and there's like a hand class, right? And the hand class depends on the pile class. But you sort of want to assume that the pile class does what it does. I only want to test the hand class.
Sure.
Like just the hand class without depending on what the pile class does.
Yeah, I mean, if we were talking about doing, like, creating classes that inherit from other classes, it's not super common in JavaScript, but you can do it. It's just a matter of you writing tests for your base class, this pile or hand class, right? And then any of the subclasses from that, you can just choose to write tests only for the additional features that subclass provides, and assume that the features that its superclass provides have already been tested. But I'm not sure how that relates to faking data and making fake data.
Well, but what I was saying was it's faking what the pile class does. So if the pile class shuffles it,
I see.
Yeah, your hand class does not depend on the shuffle method because the hand class only depends on what it really does. I guess I'm not being clear.
No, I mean, I think I kind of see where you're headed. And there are ways to, I mean, there certainly are ways where if you have a method that relies on another method, right? Like, so let's say we have a method that's going to give us back an array of 52 cards, right? And internally, it uses another method to generate a single card, right? So it'll call create card 52 times to create us our 52 cards and then give us back an array, right? So we've got a function that uses another function, and we want to test the create deck function. We don't really want to test the create card function. We just want to make sure that it was called correctly, right? So there are tools to say that there are tools in JavaScript that will allow you to temporarily override what the create card function is and does so that you can test the fact that the create deck function calls that function properly without actually calling it.
Yeah.
So that's getting into some very specific, very, I don't know, very implementation specific testing, right? You're getting, you might call these, you might consider the fact that these might be brittle tests, and the fact that like your tests have a certain amount of knowledge about what they're testing, and the more knowledge they have, the more likely you are to break those tests by changing the way the thing works, right? So if I'm testing create deck and I don't care about how it works and I just expect what it gets back, then my test knows less about how create deck works. But if my test is going in and knows about create card and is hooking in and temporarily messing with that function that's being used by this other function, I know more about how create deck works, so it's more rigid. They're more tightly coupled, so they're easier to break. Does that make sense?
Yeah.
Yeah. So that stuff will come as you get more and more challenging testing situations, but you really shouldn't need to be doing mocks and spies and stubs and stuff at this point. Is my sensible. All right, that's time. Thanks everybody.
Thank you.
Thank you.